G'day guys, Mac with the Outer Circle, and today we're going to be looking at 3D printing. Here is two of my printers here in my lovely workshop. Give you an idea of just one side of my workshop. That's what it looks like. Got an electrical section over there. The saw, which is level with the benches either side of it. The end is where I keep screws and all that kind of jazz. And of course there's a massive amount of clamps over there, which are very handy when gluing together prints. So in any case, 3D printers. So we're going to be talking today about two different types of printers here. We're talking about FDM and SLA printers. I will cover off on each of them individually in this video, so we'll cut to that in a moment. But as you can see, something of the setup. So with the FDM printer, I have these trolleys. These were pretty cheap trolleys. I bought them from Kmart, and I picked them because I'm able to take the printer around on them, move them around the workshop, and it means that I'm not restricted to having to keep it in one area. And eventually I'm going to put this Anycubic Photon over here onto one as well. The printer I'm using today is an Ender 3 from Creality, and I have 3 Creality printers, hopefully 4 soon, but we'll see. We'll see what my wife can stand. I will talk about my printers, and I'm going to talk about the problems I've had, the things you can achieve with them, why you would want to buy them, all this sort of stuff. And we're going to go pretty in depth here, so prepare for a lot of knowledge to be laid on very quickly. And this is what I'm going to call sort of layman's knowledge in a way. It's aimed at the person who's never printed in their life and they think it's too hard or too difficult, or it's just overwhelming as a prospect. And maybe some people who've just started printing but have some faults they're not sure about. I'm going to explain a lot of them to you. And this is aimed at giving you everything you need to know to start hobby printing. I'm not talking mass production printing farms here. No, I want to give you basic information when it comes to printing. And it's mostly going to focus on FDMs today. But I will talk a bit about SLA printers, so prepare for that. So before we get started talking about this particular printer, the first question I have to ask is, what is your hobby goal? Because your hobby goal will determine the sort of printer you purchase. And this is huge, guys. This is the beginning and end of all of your problems right here. If you want to produce small, finely detailed miniatures, such as a Battlefleet Gothic ship, okay? Or something like this RTLW miniature here. These are perfectly done with FDM printing. I can try and zoom in on that just to give you guys an idea of the quality of part we're talking about here. So very high detail parts, lots of intricacies, beautiful resin prints. That's the sort of thing you can expect from something like the Anycubic Photon, an SLA printer. Whereas an FDM printer, like this Ender 3, you can produce miniatures on it, and you can get quite nice detail out of it. So these were printed on Ender 5, which is very, very similar to the Ender 3 here. I'll show it to you later in this clip. So this is the sort of parts that you can make. Beautiful for things like terrain, large objects, simplistic models, battle mechs. And as you can see, you get these grains and textures through it. And that's all down to how the print is actually applied. And if I can bring her into focus, you can see there's a texture to the surface from the printer because of how the material is applied to it. And those striations, those indentations into the surface of the print are the big limiting factor when it comes to FDM printing. Now, there are numerous ways you can smooth it down. A nasty way, but very effective, is to use a type of auto body filler mixed with acetone. So, an example of that here. It doesn't really matter what brand it is, it's not important, but it's a 2-part filler. Comes with, you know, a little tube of hardener, and you mix them together and you get that nice pink putty. You mix that with acetone, brush it on as a thin layer, and it will fill in all of the lines in the miniature that you can then clean back. If you also print at very fine qualities or with small nozzles, you can achieve a lot of detail. I printed these little things to go on some trophy plaques, a Balrog's head, and a lion. And with just a little bit of enamel paint, it really has filled in the very fine striations that it had. And even though it's an FDM print, you can tell from the back of them, they look beautiful. Really nice, really finely detailed. But some of the really nice crisp details, like the tips of the fangs, are not perfect, because these printers are just incapable of it on the hobby scale. Now, it's not to say that you can't get excellent prints out of FDM, you can, but what's the trade-off? Print time, for a start. Print duration is a huge deal. Some of these models I have, and I've tried a lot of different settings. Some, like this one here, this was a 4-day long print, which is a very long print for an FDM, for something so small. But it has quite a lot of infill, quite thick walls, and at the speeds I was printing it, I got fantastic quality, as you can see, for this piece of terrain. Like, if I hold it in the right light there, you can just see the amount of detail to it. And the striations, the marks, the imperfections are practically non-existent in this model. And this is uncleaned, straight off the machine. This is the print quality. So that's the type of thing that you can expect from FDM, if you're willing to commit to it. Something like this piece of rocky terrain is much faster printed, with about 4 times less detail than that last one, but it also took about 1/8 of the time. So again, that's the trade-offs here. You can print, you know, some very large and impressive buildings, such as this one here, which is a demon-infested, I guess you can call it demonic Orthanc, because it's kind of got that feel of Orthanc from Lord of the Rings, you know, the tower in the center of Isengard. So yeah, that's the kind of stuff you can do with these, and I love them for that, because I'm printing a lot of terrain at a very decent quality for an event I'm hosting. So for my current needs, that is an appropriate use of the medium. You can also print things in multiple parts, such as this here, and join them together, where each of these large step sections is a separate section, which I glued to this oval section here with the archways on it. And this is a lovely centerpiece of terrain for a table. So for me, that's what I've been doing, and you save a lot of money printing in this fashion. Printers are expensive to a degree. I have an affiliate link for Creality if you are interested in purchasing a printer like this. That affiliate link will pop up in the video, but it'll be in the top of the description of the video below it. If you go there, I might get a cut of the proceeds, I might not. It doesn't really matter if you are interested. I very rarely shill for anything, but these work, so I am happy to shill for that. Now, getting into this a little bit, there are obviously the 2 different types of printers here that I mentioned a moment ago. So in this case here, you have an FDM printer. So what does FDM mean? I've said it several times now. Well, it means fused deposition modeling. So up the top of the printer, we have a spool. This spool here holds our filament. In this case, it's a PLA+. This material runs down and into our extruder here. So the extruder is a material feeder, is a stepped motor. So what it does, it spins around a little gear here, and it will pull the material through. That material then runs into what we call the hot end. The hot end of the printer is a 2-part thing. It's a radiator and a nozzle tip. And the nozzle tip is heated, but the radiator is cooled. The idea is that we don't want the material in this tube that's feeding in to liquefy, because it's going to cause everything to spill out and such. And the nozzle, well, we heat it. So the nozzle, hot, and that's the part of the hot end that, you know, is hot. Not the greatest description ever, I suppose. But the radiator, yeah, is there to prevent the material from melting further than it needs to. So we really just want to melt it right at the tip. And that's what this fan here is for in the front. This fan on the side is blowing cool air across the plastic as it comes out the nozzle and allows it to cool and adhere to itself on the bed of the machine. So that's all there is to that process, really. It's quite simple. The beauty of the FDM printer is that because it's such a simple process, it's quick. It's quick and it's effective, and the parts are pretty strong. The way this particular printer works is we power it up. This is an Ender 3 Pro. Now the beauty of the Pro is that it comes with a few extra little things that you don't normally get, such as the better Meanwell power supply. The regular Ender 3 doesn't come with. It also has a better extrusion. So the aluminium frame that makes it up at the bottom here is larger and stronger. So you get better print accuracy. One of the things you'll get with these printers is magnetic beds. And they're good, they work. If you want to print anything other than PLA, you probably want something like a glass bed. And I've upgraded this one to a glass bed. Glass beds are excellent. This one here, they call it carborundum as the coating, but at the end of the day, it doesn't really matter. What it is it's a ceramic coating just to help things stick properly. When you use one of these printers, let's just say there are some safety concerns. FDMs are more safe than most, but during its operation, the axis on the X, this hot end, moves back and forth. It's 200 degrees, so you will burn yourself on it when it's running. The Y axis also moves back and forth along here, and of course the Z runs up and down. You can get your hand trapped and caught in places. That is a safety concern. The different types of plastics can also give off different fumes as they melt and deposit onto your workpiece. Those are some of the things you have to think about when it comes to these printers. There are additional safety concerns with the SLA, but I'll cover that when we get to the SLAs. So some points to note. Print volume. Print volume is huge. These printers here have a pretty decent print volume for a beginner printer, and I highly recommend this as a beginner printer. But I'll get into more of my recommendations in a moment. With this, you have a decent amount, 225 by 225 by I think 300 in height. So you can make a building that's this size minus the little finny tips on the top. And I mean, this is not a small building. So scale reference, that's a Space Marine. And you think I can buy one of these reels of filament for about 25 Australian dollars, so let's say 20 US dollars, something like that, maybe a bit less. And that material I can make, you know, two or three of this whole building. So you can see why investing into these things is it's money in the bank. So print volume has, you know, a fair bit of it. But a big problem with these, well, two. First off, print volume, as in sound. When this thing's running, it's noisy. The stepper motors, to give you guys an idea, I'll just move the axes around. Let's pick Z. I don't know how well you can hear that through this. Believe me, it's noticeable. So, noise. Noise is a big deal. It's alright for me. I have a workshop that's away from my house. I have 3 printers constantly running in my workshop, and I have them off at the moment. But noise is a big deal, and this is not a quiet printer. When it is running, it is noisy, and it's an annoying whining noise that constantly is in your ear. You get over that after a while if you're running constant long prints that are going overnight. So if you're going to buy a printer like this, that is a major consideration you have to have, is do you want that noise constantly in your ear all night. If not, then you've got to look at either buying one of these and upgrading it to a silent stepper motor controller, or you have to pay for a more expensive printer, which is quieter. That's the trade-off. So you could go to something like an Ender 3 V2, which is the next model up from this. It has a quiet stepper motor, so when it runs, it doesn't go In fact, you'll find that the fans will make more noise than the printer when it prints, and I find that with my CR10 V2 printer. So that's something to take into consideration. The other thing to take into consideration is the size of the printer. So while you have 225 by 225 by 300 volume for building in this printer, it is taking up 500 by 400, well actually it's 500 by 400 by 600 odd in height with the spool included. That's a bit of space, and people who live in small houses, things like that, they won't like that as much. Whereas the SLA printer that's over there is 200 odd by 200 odd by 450, something like that, 500. Not huge at all. So constraints wise, that's better for space. Would this be the printer I recommend to people? I don't know. It definitely has problems. What are those problems? Well, this is the stuff you don't get told when you go to buy these things, and I will tell you now. Bed leveling. At the bottom of the bed, we have bed wheels for leveling it. Now this is important because the bed and the nozzle need to talk to one another, and the bed level is determined by these wheels underneath that you wind in and out, and they've got springs, and it will level out the bed so that all the different axes of the machine are flat in relation to the bed. Great. These springs are terrible. The stock springs, I can spin that wheel and it'll drop off. Like so. That's how loose it was. The springs did the sum of jack. So spring upgrade, major thing that's got to be done on these printers if you're going to buy them. That's probably been my biggest bugbear. What does it look like when that turns to crap? The prints don't adhere, the nozzle comes along and it knocks the whole print off your printer, and all sorts of other issues. It's basically the worst thing that can happen to you. So terrible. Another major problem with these, the belts. So the belts on this printer, how it runs. It's a toothed belt, runs around an idling gear, which is how you tension it by moving this gear out, pulls it tighter against the driving motor, which is back inside the housing on this side. So these belts, if they get loose, they can skip a tooth. When they skip a tooth, it skips a layer. What does it look like when it moves a layer? Well, this here is a failed print. As you can see, that line there inside was supposed to be in line with this. The whole print has moved that way about 6 millimeters. That 6 millimeters that it's moved that way has completely ruined this print. If I kept printing, these two halves would print offset to one another, and it looks crap. So terrible, terrible. Don't want it. What it should look like when it's done correctly is that. So that's your trade-off. You don't get a good part. So belts are hugely important, and they can be a pain for people who are not used to it to tension. You can buy upgrades for anything you can think of on a printer, and belt tensioners is one of them. So if you're going to buy a printer, it's something I recommend. Another thing that I've done on this printer is that extruder. So that red extruder back there, the anodized aluminium extruder, I had a lot of extrusion issues for a while there, and for a month I couldn't figure out what the problem was, because you type in things like the plastic failing to correctly extrude, for instance, and they don't tell you, like you know that it's not coming out right, but they don't tell you what's causing it. I can tell you what's causing it without having to be a genius who's done all this before, guys. this is what's causing it. This here, which I'll pull out, is the original extruder that came on this motor. So there's a difference. You have anodized red aluminium or black plastic crap. This is crap. It either breaks like this one has, this is the one I was using, or it flexes because it's plastic, it's soft. As you can see, that's a game ender. That completely stuffed this printer up. And it wasn't until I pulled it apart that I knew what the problem was. And so the solution is that solid aluminium bad boy right there, which has it's just better in every way. And the thing is, it's not expensive. That's about an $11 upgrade in Australian currency. I think I got one for one of my printers for $7. And when you buy something like an Ender 3V2, the upgrade from this one, or the next model up, I guess, what you end up with is you end up with these being a standard item because they know that the plastic ones are terrible. I mean, what the hell are you going to do with that? It's broken. It can't apply tension. Every time you try to apply tension, see, it flexes away. That's a major limitation of the technology. So, if you learn anything from me today, anything at all from running this sort of equipment or getting into this equipment, make sure your extruder is metal. Make sure your bed correctly levels and make sure your belts are tensioned correctly. You do those three things, you're going to save yourself an incredible amount of agony. Anyway, let's move on from... Oh, there's one other upgrade I made actually before we move on. I added heat sinks to the stepper motors. A bit difficult to see, but just you can see it. They're adhesive with 3M adhesive tape, and they take away all the heat, very good in the Australian summer, from those motors. When it's 40 odd degrees Celsius outside and you're still trying to print, you don't want to cook the electronics. So just a handy little upgrade that I've done, and very basic and very minor. The only other downside of these printers is the interface that you control them with. It's pretty basic. So it looks like a touch screen. It's not. You've got to use a dial you press the dial and then you can scroll through it to go into the different sections that you want. It's a pain, especially with prints. Like if I go into print from the card, then the names, especially if they're long names, you struggle to find out what means what. So I have to cut them down considerably with different letters and such. I know it's very hard to see because of the camera settings, forgive me. Very hard to see what the names actually are because they run off the screen and it doesn't scroll it back across or something. So if you have a name that's too wide for the screen, you simply miss the back half of it and you've got to guess what the print actually is. So that's a limitation of these printers. But again, I still highly recommend them. Anyway, let's move on to the next type of printer, SLA. Alright, so SLA printers. Now again, just a quick reminder, these are the ones for your high detail miniatures. SLA printers do exactly that. Now how do they do it? Well, SLA, it stands for stereolithography. And you have a couple different ones, laser, or you can have RGB and monochrome LCD screens. That's a lot of gobbledygook for most people. I get it. But again, this is all about what the hell printers are and what they do. So, they use resin, and the way this resin cures is cures with ultraviolet light. You can use a laser to create that ultraviolet light, or you can have an ultraviolet light in there, like on this printer, and you use an LCD screen to black out these sections that you don't want exposed to that light. And there are two types of screens. RGB, your standard ones, which is what this bad boy has, or you can have a monochrome. Now the monochrome is better. It is a black and white LCD, and that means that instead of having two layers of liquid crystals in there, one for the color, one for the black and white, or the black and nothing, I guess, black and white, instead of having those two layers that the light has to diffuse through, you have one layer, and that means that it's much faster and slightly improved quality print. That's the trade-off. But on top of that, the price. The price goes up a lot for a monochrome. However, I highly recommend it. This printer is brand new. I haven't used it. I have used them before. I've used them at a couple of friends' places. The first time I got to use these was at Hobby Camp over in the US with Ryan Kimmel. And he took me through basically everything on these. And I've used them a couple of times since with friends. They're very user-friendly printers. I highly recommend them. Creality, even though I have a link in this video to them, I haven't tried their SLA printers, so I can't speak to their quality in that regard, but I imagine they're quite good. Now, the way these work is you have a build plate, which is what this guy is here. The build plate on this essentially prints upside down, so the miniature adheres to the bottom. It goes right down to the bottom of the resin bath, and it projects the image onto it, and it will slowly raise its way out of there, and your miniature forms from the feet to the head, I guess you could say, but upside down. It's an interesting technology. Now, unfortunately, these things are, I can't say hella unsafe, but they are not the nicest piece of equipment to use in the safety regard. The resins that they use are rather toxic, which means that you don't want to be exposing children to them, and you don't want to be exposing yourself to them. The cleaning agents you use are things like pure isopropyl alcohol. This stuff is also pretty nasty, so highly flammable. This is a massive skin irritant, so whenever you handle it, you want to be thinking gloves, possibly a face mask, and probably goggles. Yeah, goggles, mask, and gloves. You want decent latex gloves, probably double layer them if you're going to be handling isopropyl alcohol, because they'll become brittle as the alcohol eats into the gloves. Even kitchen chemical gloves, that kind of thing, great. The resin, it will cure in ultraviolet light. That means sunlight can cure it. So when you're done with your prints and it's not doing anything anymore, you can unscrew the tray on each side. You can see there's a little divot cut into the side of the tray that allows you to pour it back into the resin, or through a filter preferably, back into the resin receptacle that you pour the resin from. When it's printing and you don't want any ultraviolet light or such to expose to it, I highly recommend you put the top down and then place a object over the top. Something thick and heavy, so not like a plastic bag, but think more like a black tub or a small bin from a hardware store, Home Depot, a supermarket, whatever, that covers it to prevent the ultraviolet light, because even though it's got a protective UV screen, it will still get in there and it can ruin any resin in there, and if it goes hard in there, you're going to have a bad time, guys. So don't let it happen. When it comes to controlling these things, touchscreen. Touchscreen is how it's done. So I'll quickly pan down on that. Again, I understand that with the light, it might not be the easiest screen to read, but they're pretty good. Unlike on the Creality Ender 3 with the old school wheel dial, on these you're able to just simply touch screen your way through. And it's pretty intuitive. So great little system. When the prints are finished, as I mentioned before, isopropyl alcohol, they have to be pulled out, very delicately broken off the plate, and then washed, cleaned, and usually leave them out for a day or two on a bright windowsill to cure fully, because deep down inside sometimes the resin can still be a little bit soft. Several companies such as Anycubic, Creality, they sell wash and cure stations. These are pods about the same size as the printer, and they allow you to put isopropyl alcohol into them. They will cycle it like a washing machine, wash the miniature for you, wash all your working parts for you, and then you can put the miniature back in there off the build plate, and it will also turn on the UV lights and cure it for you. So great little things, highly worth investing in if you're going to do SLA printing. So something to keep in mind. With the other printers, such as the Ender 3 I mentioned, things like bed leveling springs, pulleys, extruder motors, they're all major issues. What are the major issues with these things? Practically none. That's the beauty of them. It's a process where you simply pour resin in, make sure that the build plate adheres on the first layer. That's the thing that will end your... If it doesn't adhere on the first layer, you're stuffed. So that's the thing that has to be avoided at all costs. If you can get it to adhere on the first layer, then you're pretty much laughing. It'll just run its way through, and it'll take quite a while, because these are fine detail, and the finer you set the layer height, the amount of height between each exposure that it does on the resin, which sets the material, the longer time you take on the print by dialing that down to the smallest possible layer, the more detail you'll get. And you can get some incredible miniatures out of these things. And this type of technology is how Games Workshop produces their miniatures in prototype form, and it's how Forge World produces all of their miniatures. So fantastic. The other downside is, remember how I said I get PLA Plus for about 25 Australian dollars, and I can build, you know, tons and tons and tons of terrain like this. I can make 4 pieces of terrain this size. Actually way more than that. It's only about 100 odd grams, 160 grams, something like that for this piece, and you get kilo rolls for $25. This stuff is, well, it really depends on the brand you buy, but if you buy, say, I've got some Elegoo resin, that was $20 for 500 mils or something, so that is not cheap. The resin is very expensive, and you can really go through the stuff. The other major limitation of these machines, actually, which I haven't touched on, is the volume. So with the other printer, I mentioned volume in the house, volume of the machine, and the volume of product you can make. Well, the volume of product you can make in this is limited to that build plate. And as you can see, that build plate, compared to this building, yeah, this building is almost the size of this printer in raw surface area. In fact, on my CR10, I couldn't print this machine. It wouldn't work, but I could print it. That is a huge limitation, because it restricts you to doing something that's no bigger than about 5 inches by 3 inches, give or take. So, you know, 110 millimeters by 90 millimeters, 120 millimeters and something in that ballpark. Huge restriction, but it's going to take up less space in your house, and it's rather quiet when it runs. But again, it's not just a one-off investment. You can buy these without a wash and cure, but the wash and cure is so good at what it does, and it saves you so much effort. You kind of want to buy them together, in which case you're going to be looking at 400 Australian dollars, probably straight out the gate, even online through third-party sellers, to get an Anycubic Photon and a wash and clean together. If you're going to buy something like the Ender 3, you could get an Ender 3 complete base model that's going to be a little bit noisy, and it's not going to be perfect. You know, you'll need to tinker with it, you'll need to add things to it over time, but you'll be like half that price. So that's the trade-off there. That's it. That's printing in a nutshell, guys. When it comes to running parts, they're very much plug and play. The software is incredibly easy to use, and what makes them look like they're a lot of effort and a lot of detail is just how fine into the detail you choose to go. But that's a choice that's on you. You aren't forced to make that decision. That's something you undertake off your own back. And if you want, you can go in and just use the automated slices that are built into these programs that they supply with these printers for free. You don't have to pay extra for that software. You just go in, drag a file over for free that you found on, say, Thingiverse, and then click slice. It'll slice it for you, save it to the SD card or the USB, depending. Plug it into your device, and then away you go. Fantastic process. So yeah, I highly recommend it, guys. I'll also show off my CR10 V2 before we go, because I want to talk about that a little bit more. Alright, and this is my CR10 V2. It's a little bit bigger than my Ender 3. This is my Ender 3 Pro. So pretty much can fit the whole printer inside it. What does this thing do? This thing here allows me to make very big things. Not huge, there are actually bigger models than this that go up to sort of 600 by 600 build size. This is a 300 by 300 glass build plate on here. Came with upgraded springs, came with a better extruder, came with a filament runout sensor, which is something I didn't mention. These can run out on your mid-print. This thing will know when it runs out mid-print, stop printing, wait for you to put a new spool on. When a regular printer runs out, it will just keep printing and print air. Not ideal, is it? So, cool to upgrade. It has silent stepper drivers. Fantastic. It's also very rigid because of these arms. They call it the golden triangle over at Creality. It's a little bit of wank, but it is true. It does make it more rigid. Just ignore the brand naming. Downside. It's detached controller box. On the upper end models of this, the controller box is built into the base. Fantastic. On this one, it's not, it's separate. And because of that, the spool comes separate and it's mounted to here. So if the jam's up, for instance, the filament gets caught and wants to pull the whole spool, it's going to pull this whole box and flip your electronics over onto the SD card and probably break something you don't want broken, such as an SD card inside the head unit. So, me being me, I took one of these existing tables, made a new top for it. This is the top, and I put the spool holder directly on top of it instead. On with that, I still have all my drawers and such for all tooling and spare parts, and I have got some Allen keys here. These cost me $9 online instead of cheap T Allen keys. But they're fantastic for doing work on these printers because nearly everything on them is held together with cap head screws for Allen keys, or pan head screws depending on the part. So pan heads up here, some cap heads down here. This is better than the supplied Allen keys that it comes with. I also have a set of spanners over in the other printers, 7, 8 and 10 mil spanners, and I have a 6 mil spanner screwdriver. So it's a screwdriver with a 6 mil socket on the head of it that I use just for undoing the tips of nozzles when I need to do tip replacements. So it's something to look into. This printer here is fantastic. You buy one of these, you pretty much don't need another FDM printer ever. And straight out the box, there's pretty much no upgrades you have to do this. Comes with a glass bed, comes with rigidity, fantastic cooling unit, excellent extruder system, and it's silent. When this thing runs, the fans in here and in here are louder than the actual machine running. So ideally, perfect starter printer, but it's expensive. So that's the trade-off. This is over $5,000. I got this one at auction, $222. So if you hunt around for them, you can find them brand new in box for quite cheap. At $222, you can't mess with this. It's fantastic value. But you're probably going to be looking on eBay and even from Creality themselves in a sale, probably around 540 Australian dollars. Potentially more if you are outside of the right season or you're in different countries. I can't speak to that. The other thing it has dual Z-axis, so the screws that wind it up and down for the height, it has one on each side, so it stops the sag and droop that can occur across the X-axis as it moves up and down, because these things, they have a little slop, they have a little backlash. So again, another trade-off that you have. This thing is it's so good. I also have an Ender 5 on the other side of the workshop, but the Ender 5 and 3 have very similar principles. The 5, the bed moves down and it's what they call Core XY. It's a little bit different. But yeah, I just wanted to show this as like, this is the big end versus the end of 5 at the the end of 3 at the small end. Fantastic printers, really rate them. If you want to print terrain like I am, you can do an entire table with a printer. Something like an end of 3, probably pick it up, 2 spools of filament, and print an entire table of terrain for under $300. It can be done. For me, I've got to do 14 tables, and so having 3 printers and spending $800 on printers, another $800 on filament, is okay, because I'm doing 14 tables, and I'm doing stuff for friends as well, and I'm doing stuff for Cat, and I'm doing stuff for giveaways, and I'm printing out a whole bunch of stuff for myself, even on the side, and I can do all that, and it's cost effective. So again, tying back into the very first question I sort of asked, what is your goal out of the printing? If your goal is to print terrain, and you want to print a lot of it, multiple tables, get one of these. If you want to print a table, and get an Ender 3. They're a fantastic printer, endlessly upgradable, and a huge amount of advice online about how to do it. Fantastic printer. If you want to produce high quality, fine detailed miniatures like Games Workshop straight out the gate, buy yourself something like an Anycubic Photon, or one of Creality's offerings. It's out there. It's up to you what you pick and what you do with it. Anyway, I'm Mac with the Outer Circle. Please, any questions you've got, hit me up below. Remember, I've simplified a few things in here, such as layer height and such. I didn't get too far into it, but they are very important things. I didn't discuss bed warping. Again, important thing, but it's not something you need to worry about as an initial printer, in my opinion. I can come back and revisit the subject specifically if people want that. We'll see how we go. And like I said, if you want to buy a printer like this, you feel a little confident, feel free to click the link I'll supply, go shop with Creality, and we might see something on the back end, although I highly doubt it. But yeah, thank you all for watching the episode. Hope you got something out of it, and I'll see you all next time.